Let x be a discrete random variable representing test scores, which are whole numbers. The distribution of x can be approximated by a normal distribution with mean mu equal to 687 and standard deviation sigma equal to 97. Evaluate the following using standard normal cumulative distribution function, CDF, uh, phi, and the table provided at the end of this document. Use the continuity correction for whole numbers scores. So the first part is asking the proportion of scores between 600 and 800. When we're doing the continuity correction, basically, let's say Z1 is going to be this is the lower value, so I want to go below that, and that's the 599.5. I want to go 0.5 below that. Then minus the mu, which is 687, divided by 97, and then I want Z2 to be, now that's the top one. I want this to be inclusive, right there it says inclusive. So I want 800 to be included, so I have to go above that. And then again, subtract the mu divided by 97. I think the first one is about negative 0.9. And then the second one is about 1.17. So to find the probability of x between 600 and 800, I have to approximate that with phi of 1.17 minus phi of negative 0.9. I know my table only contains negative z-scores, so I have to figure out how to convert this. Let me see. So on this phi, that's the area that is associated with that. So when I'm trying to find negative 1.17 is this area. And that is 1 minus, so I can write this as 1 minus phi of negative 1.17 minus phi of negative 0.09. And then we go to the table. Okay, so negative 0.9, that's a probability. And what else did we have? We had negative 1.17. So 1.17, I have the truncation, negative 1.1. This is the 0, 1, 2, 3, 4, 5, 6, 7 is right here. So now I have both values, and I can use them to compute the probability I needed to compute. So this is 1 minus 0, 1, 2, 1, 0.1. So this is 1 minus 0.121, 0, 0, and minus 0, 1, 0.1, 8, 4, 0, 6. Let's see the cutoff mark for the top 20 percentile of the score. If you go back to the table again. In the table, I can see that the low 20 percentile is negative 8.01234. So negative 8, negative 0.84. So what we found was the low 20 percentile, which was negative 0.84. Now, look at the curve. If negative 0.84 is a low percentile, the top percentile is associated with 0.84 z-score. So the z-score for phi inverse of 0.8, which is the complement of the upper 20 percentile, is equal to 0.84. Now, to find the x value, or the score of the student's value, you are going to multiply c of 0.8 times sigma plus mu, which is 0.84 dot sigma, which was 97, plus mu, which was 687. This is approximately 768.6. Oh, so it actually includes anything that is above 769 and above. So the cutoff is 769. Next part of the question is asking what is the cutoff mark for the bottom 15% of the score. So now if I look at the table again, I'm not going to go back to the table. The phi inverse of 0.15 is approximately negative 1.04. So to find the score, x is going to be the z value times the sigma, or standard deviation, plus the mu. And that is approximately 586.5. Now I want to go below, so I'm going to go, I'm going to say the mark, the cutoff mark is 586 and below. It's asking, the next part is asking the proportion of score above 800. Again, you want to find the z value. Because it's above the 800, meaning that 800 is not included, you use 800.5 for the continuity correction. Subtract mu, divide by sigma, z-score approximately 1.17. Um, to find the value of the probability of x bigger than 800, you need to compute 1 minus phi of 1.17. If you're only using again in our curve, this is this area, and it would be equal to this area. So you need to compute phi of negative 1.17, which is approximately 0.120. Now, this part of the problem is asking find the score x such that the probability of the score is minus mu is between negative x and x. So how do we do this? Let's say this probability is equal to the probability of minus x over sigma, x minus mu over sigma, and x over sigma. So that is the probability of a z-score being between uh, negative x over sigma and x over sigma. That is phi of x over sigma minus phi of minus x over sigma. Let me look at the picture again. This is the probability of x over sigma, and then I have negative x over sigma. So basically, this probability is just 1 minus the other probability. That is 2 probability of x over sigma minus 1. 2 phi of x over sigma minus 1 is equal to zero point 0.5, or phi of x over sigma is equal to 0.75. This also tells me that phi of x negative x over sigma is 0.25. From the table, I find negative x over sigma is equal to phi inverse of 0.25, which this value is approximately minus 0.67. Now let's try to find x. So x is equal to 0.67 times sigma, which is 97. And that is approximately, this is approximately equal to 65.4. And we don't want the values to be included. We want to find the values that are excluded. So for x minus mu should be between 66 and minus 66.